Okay, welcome to Cloud Training for Enthusiasts. My name is Usato Hamen Patrick Aigbogun, and we are here to really drive home the Kubernetes itself. And our plan today is that after today's class, you should be able to understand the principles of Kubernetes, the infrastructure behind Kubernetes, and how to use Kubernetes. So to do that, there's no how we understand Kubernetes without knowing what we call what. So we are going to build on the past classes that we've been having. And the last class we had was on Docker before we move into Kubernetes. So we took time to explain all the basic fundamentals and why of Docker. And we did some courses, we did some hands-on on Docker. And I also explained the reason why Docker is most preferred and is widely used compared to every other aspect. So we took time to expatiate that, and we're able to establish that thoroughly. So what I'm also saying is that if we can successfully understand that, that means it will be going to be easy for us to understand Kubernetes. Now, Kubernetes is not like a regular VM. We already know. I remember I've explained. We have talked about this. Now let me go to a course that we've talked about this. You understand the VM principles. Hold on. Let me just go straight. So now, I was talking. This was the illustration we did last time about Kubernetes, about Docker. We said this is a server. This is a single server. When you divide this server, if you install an hypervisor on this server, you can virtualize this server, meaning you can make this server you can divide it into different virtual machines and allow those virtual machines to operate as if they are single VM. They are single machine, but they are not really a machine. That's why they are called virtual machine. They are not a physical machine, but they are part of a physical machine. They share resources of a physical machine. So when you divide, this is a physical server. If we install an hypervisor, you'll be able to virtualize it. And when you virtualize it, which is a VM, you can install an operating system, which could be Ubuntu, Mac, Windows, and CentOS. Then after you install an operating system, then you can now go ahead and start installing an application. So I said that the technology called the Docker technology, which instead of you to be installing all the application and their payloads, you just install only the application and a little bridge in relation to the particular operating system. For example, if you are installing CorelDRAW, instead of installing CorelDRAW that's supposed to be like 4 gig, you only just install the CorelDRAW and the little patch that is related to the Docker and the VM. So if I'm having a Docker VM here, and it's an Ubuntu Docker, installing Docker, the application I'm going to zip here must be Linux or related, Linux Docker related. And then when I do that, what happens is that instead of me to start bringing all the things that is not necessary, I will only just zip only the application image and create a container out of create a container. A container is just like an application virtual machine that allow you to access an application instance. They allow you to compute and work, and you allow the application of every other application. Okay, I think that is the right word. Consider this as a Docker container. So if you see this Docker container, despite is still inside a VM, this application inside this container can work in isolation, can work on its own. You can access this CorelDRAW using the port of your VM to access it. Just like what we did last time, we bind the port of this CorelDRAW we actually use the Nginx, right? We did an example of an Nginx. Let me put an Nginx here. So we put an example on an Nginx. Then we're not buying the port 80 to port 80 of the system, of the machine, and we're able to access it through the local host. That was what we did. So this is a container. That Nginx is inside a container, meaning is in an isolated infrastructure, an isolated space, application space, what Docker help you to do. So instead of zipping all the things you need, all the things you don't need, you just put only the application. So here is what a Docker does. Now, what is the Kubernetes? You can see this Docker, this is a Docker container. This is a Docker container. This is a Docker now, assuming we have Cubectl here, we have Cubectl here. We have to Cubectl here. We have Cubectl here. We can decide. Remember, we have our Docker. A minute. Just give me a minute. All right. Today's class is very, very interesting. And I know there are so many challenges that is trying to come up, but overcome all of them. Hold on, let me delete some space. Hold on. Okay, can you hear me now? So all these things are Docker, right? Are containers, an application, just like Nginx with zip. Maybe this one is Nginx port 80, Nginx port 80. Maybe we'll spin up another Nginx. I'll put this one in port 81 of a local machine to port 80 of the application. It will still work. Now, if you look at it, all these engineers, they are working in different ports, right? They are working in different ports. So that means they are working in different ports. This one is working in port 81. This is working in port 80. You can notice that if you want to be serving people, imagine you sending port 80 and port 81 to people. Say, okay, you can access my application in port 81, port 80. It will look so annoying. So that's why you have to bridge both of them in with either a load balancer. You have to create a load balancer or another application that will be linking all this load balancer and be serving load. But you can see for this application, they are working, they are in isolation. Maybe if we have another one, maybe my SQL as an application. And this my SQL is going to be in its own port at port 3306 in your system. Then you can bind it to, port 500 of your local machine or port 50 as you want it. Yes, of your local machine. That means this Nginx, for this Nginx to talk to this application. For example, remember I told you, like when we were doing our PHP application, your PHP, let's assume this is our PHP application, PHP, and we can keep PHP at port 500. So assuming we have PHP, and this PHP want to make use of this SQL, because for you to have a LAMP application, you need PHP, MariaDB, which is also MySQL, and Apache. Now, this is already running on Linux, so which is a LAMP, complete LAMP stack. So that means this one and this one have to talk to each other. So for this and this to talk to each other, in the Docker settings, you have to allow this one to have port 80, port 50, port 500. You're going to allow this one to have port, for port 505. This one will now have port 505, 500. So for them to communicate, you write a what we call a Docker compose file that will bind this and this together for it to work. Despite you are binding them together, if this one goes down, the application, this one will no longer work. If this one goes down, this one will no longer work. So this was the challenge that Docker were having. So Kubernetes now says, instead of us having those Docker working in isolation, why not have a situation whereby an application will be managing everything? Something will be managing all the application inside. So what do I mean? I mean, let's put it this way. Now we have our, let's copy this, Control-C. Put it back here. Control-V. No, sorry. Control-Z. Okay. Now, this is a Docker. We're going to set up another Docker. Let's assume that this is our Docker engine. This is our Docker engine, Abi. Let me make it blue so that everybody can still understand what we are doing, that we are still in the same Docker ministry. Okay, this is our Docker engine. This is our Docker engine. Now, we have let's put this one, let's call this one PHP. And we now have another application, another Docker engine called MariaDB. Let's call this one PHP. This one is what? MariaDB. DB. Then we have, we will still have what we call Apache, right? That we expose it to the internet. Then we now have another one called Apache. For us to run this, we have to run them in separate Docker container. This one will be on its container. This one will be in its container. And this will be in its container. So because it's a LAMP application, this is a Linux application, we are going to expose, just please take note of this scenario, this illustration. So we're going to, let's assume we are exposing this one port 500. Let's say port 500 is just an instance. Maybe for MariaDB, we expose, we open port 3306. For Apache, you have to open Apache or Nginx, you have to open port 80. Port 80 or 8080, anyone. So meaning for this and to communicate with this, we are going to bind this to port 3306. Then bind this one to port 33, port 500. Can you hear me? This one is port 500. Now, for this one to work, you are going to bind these three ports together. Now, this one, this is communicating with this. Why this one is communicating with this? Because this is the UI. Please take note of this illustration. This one is carrying this database. So it's saving everything that the users are doing. It's saving it in the database. Now, this is the UI. Meaning this is where the graphics user interface that we are using is communicating. So this one communicate with this. This one save all the data into this. So this is what we will now bind to our local port 80. So if these are three containers. Now the challenge is that if this container dies, maybe somebody mistakenly saves something wrongly into it. It goes out of the Docker, it dies. What happens is that this application stop working automatically. And if this application stop working automatically, these three things will stop working. there is nothing to, you will not see that this server is down. You will not say application is down. Nobody is able to work on the application. Application is down. So we will not have to troubleshoot it. We will not discover that it's Docker, is MariaDB that is down. So we have to either the connection, check the connection, troubleshoot it, then bring it back. So when it comes back, automatically the system will start working. This was the challenge Docker was having. Docker staying alone was having. There was no team managing it. There was nothing, you understand me? So, and they were working in different locations. Docker can be here, this one will be here, but they are working in different locations. So what a Kubernetes came to do is this. Since these three applications, they are they are working together hand in hand, right? What Kubernetes came to do, he said, since they are working hand in hand, we can zip all of them together, these three together. And call it, how do you bring it down? Good. So we will now zip these three together and call this a pod. So that's the concept of a pod. A pod is like a storage that zip applications that are working together. You understand? So instead of engineers working on its own, so in this pod, there's going to be a configuration system that will link this thing together. It's not compulsory that these three applications will be in the same Kubernetes engine, but they will be in a location that this Kubernetes engine can access. But this pod, because every deployment file, are you getting me? It's going to be managed by, you can declare your pod management scheme in a deployment file, called a deployment file. That is saved inside your Kubernetes engine. What happens is this. Well, if you tell Kubernetes that I want this application, everything about this application to be running in one, all of this, for this name application to work successfully, I want these three applications to be linked, test it if they are working, and if they are working, set it up. So automatically we will now have one replica set. Replica set means one unit of this pod. Then you can decide to say, let it be two. If you say let it be two, that means in your Docker engine, the Kubernetes engine will set up two versions. Control D. Please stay with me on this. Sorry, Control. So you now have two versions of that pod running. So what happened is this. Peradventure, one of these that MariaDB crashes. Because what is stated in this deployment file is that this is how you want your engine to work. The Kubernetes will automatically spin up another container and install MariaDB and keep it working. Maybe the PHP automatically spin it up and replace it. So automatically, what does that mean is that this application will keep running as far as the deployment file is stating the number of pods that is running. So when you hear about word pod, the pod actually means an application, an infrastructure or a storage place or a compartment. Let's use the word compartment that house all the container relating to one particular application. So a pod is a collection of a container, and that pod is managed as a single unit by the Kubernetes engine. So when you say Cubectl, which is like a language, Cubectl, which is like the command line, just like the way you use apt-get. You know, when you use apt, you are talking about a library, right? An a management tool called apt, APT. When you are in other system, when we're using Docker, we're using Docker as our management file. You say Docker list, Docker container list, Docker image list. Docker was our management file. You understand me? Kubectl is the same thing like apt. So Kubectl is our management tool that I use in managing Kubernetes. If we say Kubectl get pod, it will go to your deployment file. The pod, meaning application that is zipped together, that has all those things that has all those containers that work together as a unit. It will declare it as pod 1, pod 2, pod 3. Say this pod for this is working, this pod for this is working, this pod for this is working. Understand me? So the deployment file will maintain the management of this pod. It's all about when you say, so Kubernetes is not a different system. It's a Docker management orchestration file, a management orchestration application. That is why you can see the way they design this Kubernetes. You can see they put it like a wheel. You know, this wheel is used for boat, for ship, big ship, right? It's used to steer the ship where to go and where not to go. That is why it's called an orchestrator. So it's orchestrating this Docker. Do you understand now? Do you understand now? Hello?
Much clearer. Much clearer, thank you.
Collins, do you understand now?
Yes, I do.
Okay. Now let's look at a simple deployment file. Like that course I said you should do yesterday is that there are so many commands. There are so many commands that you run when you are running Git, when you are running Kubernetes. The commands are so much, right? So I don't want us to be wasting time testing this command. That was why I wanted you to, on your own, master this command. Like what is in the deployment file, what is in a service, the difference between a load balancer, a node pod, and a cluster IP and a node IP. I wanted you to understand it in-depthly. Because if we are to focus on it to do it here, you are going to waste time. So I don't want us to waste time. That's why I give you that assignment to just do on your own. You understand? And when you do it, you get to have in-depth knowledge about Kubernetes. So by the time we come now, we will now start practicing those words. But we cannot do it again now because why? The time we would have used, we've not completed that particular file. However, that does not stop us from doing one or two stuff. So let me show a sample of a deployment file. I have one here. I'm trying to get a simple one that is not too much. I will not make our brain go gaga. So Kubernetes cannot function without Docker because Kubernetes is used to manage Docker. Now, are you saying Kubernetes is the only is only Docker management file? No. We have other management file like we have other orchestrator tool like Docker Swarm. Docker Swarm is almost the same, like the same Docker stuff. It's used to manage Docker. They also used to orchestrate Docker. There was one application we were working with. The people that even designed the application they were using, when the company was using Docker. They didn't even use, excuse me. They did not use, I want to pick up something. They did not use Kubernetes. We were using Docker Swarm. So Docker Swarm is a product of Docker. It's used to manage Docker. So, but let's not go there. Yes, let me open. I just don't want to open a very complex, but I think with the look of things now, I have to just open one so that we can all run it through. Or even what I've done now, if you go back to that course now, you will know what she's talking about. But let's go a little deeper. Hold on. Okay, I think this is one deployment file. Let me open. It's for PHP. Let me open my VS Code. So a deployment file is that file that lists the instruction of how you want your application to run. You understand me? It tells the system the version of a Docker. Those images could be in your local system, could also be in the cloud base or another storage system. Let me try and see. A Helm chart is another way to manage Kubernetes too. If you don't want to use, these ones are using Helm chart is another way to manage Kubernetes. If you don't want to Kubectl, you can use Helm chart. Come on, where are you now? This thing is not opening. What I wanted to show is more comprehensive. I don't want to, well, hold on. Yeah, just use the one like this. Okay, I will say I will. Hello, sorry, my network is just throwing me off and off. Oh. Are you still there?
Recording in progress.
Yes.
Progress.
Can you hear me?
Yes, we are here.
Sorry, can you hear me?
Yes.
Sorry, my network is just, can you hear me since it's coming up now? Okay, let me show a sample. Let me just get a sample and let's work on that. I believe I explained this. You should be able to catch up from the next part. Now, this is a deployment file. You remember that most Kubernetes services gives you an API, application program interface, meaning an access point for you to access the Kubernetes engine. Now, if you look at this, this is a sample of a deployment file. It's different from Kubernetes, it's different from Docker. You know, Docker is to build. Docker has a file that we use to build, but this one does not build. What it does is that the Docker that you already have, it puts it inside an engine. That's why it's called deployment. Kubernetes does not build Docker. It deploys. That means it carries the Docker that you have built, the Docker container you built, or the image, it zip it together and put it inside a compute engine called Kubernetes engine. So that's why it's called deployment file, right? Now, okay, look at this file now. It said API version 1. This is for Kubernetes version 1.9 and is used for version 1 beta 2. When you are building an application, you should have to have alpha. Alpha means you are just starting. Beta means you are moved to the second stage. Then after beta, before you start having version 1. Before API version, that is version 1 now, we used to have API alpha version 1. Now we are not using version 1. So for you to know that Kubernetes is still very, very young, you can see we are still in version 1.9 Kubernetes. So this, he said the kind means the type. He said this is a deployment file. That's why it's called deployment. So we have several versions of deployment, several versions of Kubernetes file. We have service file, we have deployment file, we have service account file, we have ingress. Remember, I told you ingress is for network. So when you see this one means this is the real application deployment file. Now you say, what's the name? The metadata. Metadata just like tag. You know, when you are doing tag means just give it a name so that people can recognize it. You say you should tag it front end. Somebody asked a question, what is the front end and the back end? A front end is that part that users interact with. For example, now, every application you go to the internet and you access is called a front end. All these things are front end application. It's also known as UI. This is a front end of this Norton. This is a Norton antivirus search engine. This is the front end, right? This like this one. Let's say Facebook, or let's say LinkedIn. So this LinkedIn you see here that is loading now is the front end. But at the back end, there is a database. There are some other mechanisms that enable this application to function well, working behind the scene. They're like the engine of the application. So that part of that engine of the application that manages the database and everything is called backend. But this one that you see here is called the front end. It's also known as the UI, the user interface. So what this one is saying is that the metadata, this is a user UI application. Now it says, and a typical deployment file have API version, kind, metadata, spec. Those are the three things that it has. Every other thing is just additional. A deployment file must have these four credentials, these four parts: API version, kind, metadata, and spec. So a spec can have a sub-spec, can also have an environmental variables, right? But these are the parts, and the spec can also have ports. You know, port means the aspect of the part that you want it to bind with in the application. So now we have this front end, we have the API, metadata, I've explained metadata, selector. Selector is how you want the application to, how you want to label it. how you want the application to function, the number of, for example, in a spec, we have selector. Selector means match labels. Remember my metadata match labels, or you say, okay, what's the name? How do you want to differentiate this? How do you want to identify it? You say the name of the application should be called guestbook, right? So when you are going to look out for this application, which one, what are you going to look out for? Is it guestbook or front end? Let me just answer your question. The answer is guestbook, because the name of the application is called guestbook. But this tag, this is just a tag. So the type of tier is going to belong to is also front end, meaning this tag is something you use to tag it. It's necessary so that you can use it to separate the application. But the name of the application is guestbook. Replica means how many pods. Remember, I just explained the meaning of pods to you. That you can have 1 pod, 2 pods, 3 pods. It's the replicas is 3, meaning this is a pod. When you zip all this application together, you're going to have a pod. But that pod, please make it 3 pods. So what does that mean? If it's having a LAMP application that is Apache, MariaDB, and PHP, which is going to form a pod. So you're going to have 3 of it. Apache, MariaDB, and PHP 1, Apache, MariaDB, and PHP 2. And this 3 pod is going to zip them together. Then you're going to have a load balancer shared across to it, so that in case one of the pods dies, the other pods take over the responsibility, just like the way you also do VM. We'll call it availability and some of high availability. So you can't call it auto scaler. So replica, this is where you define your replica. Replica means you should have 3. Now, if you follow this template, this template is not compulsory. In a spec, you can have selector and replica. Template is not compulsory, but some application you can have to have a template that you can also use this template to launch other application. Now, this is also the same thing. The spec, under the complete spec, the major spec, you can also have another sub-spec. Mind you, this spec is actually following through this template. It's because they declared this template, that's why they are using spec here. But if you remove this template, this spec is supposed to be under this container. You can also put container under this spec. But now they want to have a separate template that other application can follow through. Now they said the spec container, the name of the container should be called PHP Redis, right? PHP and Redis. Now the image, meaning the application that has already been Dockerized, that is called an image. An application that's already been Dockerized in Kubernetes engine, in Dockerization. When you say an image, meaning an application that's already been built, it has already been built, that has been built as a form of a Docker image. So this image, you can see this URL. This is from GCP. This image URL, from this URL, I can tell you that it's from a Google Cloud repository. It's not from a Docker hub. If it was a Docker, you are supposed to put the Docker public URL here. Or if this Kubernetes engine have access to the private repository, you know what that means? It means that you have to authenticate your Docker so that you can have it private. So you can put the private repository, which is the standard in terms of production environment. But in public, you can put any public URL here. Yes, that means so this is the image of the front end application, meaning this application has already been built and pushed into a Google Cloud GCRO. GCRO means Google Cloud Repository. Yes, that means this is why this URL is here. So otherwise, it would have been a public URL. Now, the CPU, now resources. This resources is talking about the allocation of which was the compute engine resources that this particular application will be using. You say the CPU should allocate 100 100 MB micro hours, that is, is in MHS, is in hours, CPU is in hours. Memory, this should allocate 100 MIB. This is MHARS, this is MIB. So it's telling that this container should be using these resources. Now, this env means environmental variable. This is where you now define if it's going to communicate to any other application. Maybe if it's going to communicate to database, this is where you put your database. If you're going to communicate to another application, this is where you communicate the application. Because when the application wants to start, it's going to look out for this